So good morning, I am Dr. Sai Kiran. Today we are going to discuss about the level of significance for parametric data. Okay, before discussing how the level of significance is calculated and what are the tests we do for calculating the level of significance, we have to understand some common terminology about the parametric data. Okay, nominal data. If the data can be divided into two or more categories based on qualitative differences, and if there is no gradation like more or less or higher, or even it is greater or less than, okay, so these are called gradations, and if there is no gradation, then the data is said to be nominal. For example, if there is a class of students were divided as boys and girls, and if the drug products available are divided into tablets and capsules, okay, so there is a division based on the categories, okay, so this type of data is called nominal data. And then we see ordinal data. The data will be said to be ordinal if it is divided into categories and the categories are arranged one above the other. We say the data is an ordinal data, and we perform different statistical tests for both the nominal and ordinal data. And if you can see the examples of ordinal data, bags of lactose obtained from different suppliers can be categorized as excellent, good, average and poor. Okay, if there is the categories like good, excellent, average or poor, if there is a gradations or if there is a rating like this, this kind of data is said to be the ordinal data. If you can see the other examples, if the materials used in a construction are categorized as strong, average or weak, okay, this kind of data is also called ordinal data. And the other scale after the nominal scale and ordinal scale, the other scale we use for representing the data is interval scale. In the interval scale, we arrange the data on a scale which has equal differences or intervals. For example, the temperature scale. If you see the temperature, you say 100 degrees Celsius, 80, 60, like that. If we arrange the temperature scale, 100 degrees Celsius is greater than 80, and likewise 59 degrees Celsius is less than the 60 degrees Celsius. This range of the temperature can be said as interval scale. And the other scale is ratio scale. If we can also form quotients with the data, we call it as a ratio scale. For example, if a boy is 2 feet tall and if another boy is 4 feet tall, and if we say that the second boy is twice taller than the first boy, okay, and this kind of giving form of quotients, okay, this is called ratio scale. And the measurements of length, height, money and various amounts, weight, volume, area, for all these kind of parameters, we can give the ratio scale. And we have now discussed what is an ordinal scale, what is a nominal scale, and what is the ratio scale, and what is an interval scale. Now, before understanding various tests we perform for the level of significance based on these scales, or before selecting the various parameters, parametric or non-parametric tests for calculating the level of significance, we see the population. We should understand what is the population and what is a sample. The population is a large unit or space or gathering that is under study. Okay, the unit under the study is what? The population, and the sample is a small representation of that particular population. Okay. So the large unit or space or gathering that is under the study is called population. If a set of data consists of all conceivable, possible or hypothetically possible observations of a certain phenomena, and this can also be regarded as a population. We call it as a population. If a set of data contains only a part of these observations, we call it as a sample. Okay, so the population is a unit, is a unit of our samples, or it may also contains a hypothetically possible or possible conceivable ideas. Okay, so it is a unit of the gatherings under the study, and the sample is a small part of the population. So population may be real, and we may be wishing to study the quality of the empty large volume parenteral bottles. For example, in a pharmaceutical industry, if you want to study the quality of empty large volume parenteral bottles, if there is 1 lakh bottles, okay, then this 1 lakh bottles is our population, and if you want to pick the one bottle to study the quality of that particular bottle, then that particular one bottle will be the sample. Okay, so then our population size, or the size of the population here in this example, is 1 lakh. So as we discussed, there is 1 lakh bottles, or the population size to study the quality control of the large empty vials. There is 1 lakh population, and if you want to study and you want to pick 30 bottles at random and study them, then our sample size will be a 30. A population may be an imaginary. Suppose we are punching the tablets and we are measuring the hardness of these particular tablets, then all the possible values that the hardness may take constitute an imaginary population. Okay, for example, the observations, for example, we have punched the tablets and we are measuring the hardness of the particular tablets. Okay, the observations of the particular hardness values may also constitute the sample size. So a sample is a small subunit, whereas the population is a larger unit. A sample is a smaller subunit or a fraction of the large unit called population that we are studying. We study the sample, and based on our studies we can make conclusions regarding the population. To distinguish between the description of populations and description of samples, we use different words or symbols sometimes. And when we talk about the population characteristics, we use the word parameter. This is very important, about which we are going to discuss in the coming slides. When we talk about the population characteristics, we use the word parameter, and when we talk about the sample, we use the term statistic. Okay, the statistic and the parameter are the two important terms we use to define the population or sample. And the population parameters are denoted by the Greek letters such as mu. Okay, for example, if you want to represent particular groups, for example, if there are two groups, you can represent like mu1 and mu2, whereas mu1 and mu2 are the two different groups. So the population parameters are denoted by the Greek letters such as mu for mean and sigma for the standard deviation, and the sample statistics are denoted by the letters x bar. For example, if you want to represent the mean of a particular sample, or if you are representing the mean values, you can represent by the English letter x bar. So sampling distribution. If we take several small samples from larger population to determine the statistic or the sample characteristics such as mean for all those samples and form a frequency distribution with those of mean values, then such a distribution is known as the sampling distribution, and its standard deviation is known as the standard error of the mean. Okay, so sampling distribution mainly determines or it represents the sample characteristics. Okay, and the standard deviation of this sampling distribution is known as standard error of the mean. Now we discussed about the hypothesis testing. There are several steps in the hypothesis testing. The step 1, you write the null hypothesis statement, and how to state a null hypothesis statement we have already discussed in the previous class. The accepted hypothesis is that there is no difference. For example, if I again repeat, null hypothesis is represented by H naught, okay, or H0, where it assumes there is no difference between the two given groups or two given populations. As we discussed, the population will be represented by the Greek letter mu. I have written the mu1 and mu2 to denote the two populations, and H0 to denote the null hypothesis. Null hypothesis assumes there is no difference between the two given population. Therefore, we can write like mu1 is equal to mu2 as there is no difference. And the step 2 is you have to write your alternate hypothesis, and this is the one you are testing, okay, and therefore it is also called research hypothesis. And you think according to this hypothesis there is a difference between the two given populations. It can be represented by H alpha, okay, it can be denoted by mu1 not is equal to mu2, or you can also write mu1 greater than mu2 or mu1 less than mu2. Okay, so the first two basic steps in the hypothesis testing is you have to write the null hypothesis statement, and the second one you have to write the alternate hypothesis. Coming to the step 3, identify the information available to select the test static. Identify the information available to select the test static. Okay, so up to now we have discussed what is the ordinal scale, nominal scale, or ratio scale, or interval scale. Okay, and we have also discussed that the parameter is the term which represent the characteristics of a population. Okay, so here we are studying the hypothesis, or we are testing the hypothesis based on the sample means. Okay, so if the data is parametric, I mean if the data is in nominal scale, we perform parametric tests. Okay, and if the data is in ratio scale, we perform non-parametric tests. Okay, so parametric and non-parametric are the two types of statistical tests we use for the hypothesis testing. In the step 3, after defining the null hypothesis and alternate hypothesis, you have to identify the information available to select the particular test static. And the test 4, insert the items from the above into the suitable formula to calculate the test static. Okay, so now based on the given data, you have selected either parametric test or non-parametric test. For example, in the parametric test that's about which we are discussing, in the parametric test we have student t-test, ANOVA, chi-square test, like this. Okay, for every particular either parametric or non-parametric test, we have a selected formula to calculate the test static. So in the step 4, we have to insert the items from the step 3, I mean the selected statistical test, and its corresponding the test static formula is need to be derived. Okay, and based on the test static value we get from the step 4, you have to find the critical value for the test static, and you need to compare this critical value with the value which we have identified from the test static. Okay, that means from the step 4 we have to compare the value of the test static with that of this critical value. And the step 6 is to compare the step 4 and 5. Okay, so this comparing the test static and the critical value will be our step 6. Okay, and then based on the value we got, the test static, we compare this test static value with that of critical value, and if the test static value is less than the critical value, you accept the null hypothesis, or if the test static value is greater than the critical value, you reject the null hypothesis. So your decision will be based on this comparison. So statistical tests. One of the major steps in the process of statistical hypothesis testing involves the choice of statistical tests. We have just now discussed. The most appropriate statistical test is chosen according to the desired power of the study, the nature of the population, and that means the way the population is represented, or what is the scale by which the population is represented. So the most appropriate statistical test is chosen according to the desired power of the study, the nature of the population from which the observations are taken, and the nature of the measurement of the variable. So there are basically two types of statistical tests. One is parametric tests and the other one is non-parametric tests. Okay, first we will discuss about the parametric tests, and then we are going to discuss about the non-parametric tests in the coming classes. So what is parametric test? A parametric or a parameter in the statistics refers to an aspect of the population. Just now we discussed. Okay, so a parameter in statistics refers to an aspect of a population as opposed to a statistics or static, which refers to an aspect of a sample. Okay, so static is the term we use to represent an aspect of a sample, whereas the parameter is a term we use to determine the aspect or to represent the aspect of a population. Okay, parametric tests assume the normal distribution. Okay, if there is a normal distribution and a bell-shaped curve, okay, like in a normal distribution, then we perform the parametric test to determine the hypothesis. Okay, so parametric tests are in general more powerful and that require a smaller sample size than their counterpart non-parametric tests. The following assumption should be held before a parametric statistical method is selected. Okay, these assumptions are the data should be normally distributed, and the sample should be independent, and the variances of the population under examination should be similar. This is termed as homoscedasticity. Okay, the variables under examination must be metric, discrete or continuous. Okay, so these are the various assumptions before selecting the parametric test to determine the hypothesis or to test the hypothesis. So we mainly use parametric tests for quantitative data and for continuous variables, and when the data measures an approximate interval, and if the more importantly the data should be in the normal distribution. Okay. And the advantages of the parametric tests are, it do not require the large data processing, so it requires a small sample size, and they are quite easy to calculate them. For example, if you take the t-test or chi-square test, we can easily perform, or we can easily calculate the test statics of or the t values based on the simple calculations, and they provide all the necessary information. For example, one of the biggest advantages of the parametric test is that they give you real information regarding the population, or it gives the useful information regarding the population characteristics. And the other benefits of the parametric tests include the parametric test can perform quite well when they have spread over and each group happens to be different. Okay. However, there are some disadvantages also for the parametric tests, and they include, they are not valid with very small data sets. Although they do not require the large data sets, but they can also not be performed with a very small data sets. And the size of the sample need to be big, and the power analysis should be clearly done before selecting the parametric tests. Okay. So what are you studying here shall be represented through the medium itself in the parametric. For example, the best reason why you should use the non-parametric tests, okay, than the parametric test is that they are not even mentioned, especially not enough, and they can also do usual test with some non-normal data, and that does not mean in any way that your mean. For example, this anyhow we are going to discuss in the non-parametric tests. Okay, the non-parametric tests do not always require the mean, and the data should not always be represented in the nominal as a nominal data or normal data. So this is the advantage of the non-parametric test and the disadvantage of the parametric test. So the type of parametric tests include student t-test, analysis of variance, and the correlation coefficient or Pearson correlation coefficient, and regression. Okay, again the student t-test includes paired t-test, okay, and non-paired or unpaired t-test, and the ANOVA can also be divided into one way and two way. So in which situations we perform paired t-test, and when we perform the unpaired t-test, when we perform one way or two way ANOVA, what is about these parametric tests we are going to discuss in the coming classes. So thank you.